This is Brent with Lykins Motorsports. If you guessed enclosed cam tunnel for our guessing game yesterday, then you were correct. This is something that I have been working at for several years, and I think I've finally found an easy solution and possibly even a solution that can be easily marketed to guys with FEs who are wanting to gain a few horse ponies. So let's just take a step back and we'll say that, or we'll ask the question, why would this be necessary? So enclosed cam tunnels, they have one purpose, and that's to keep oil off of the rotating assembly. And in a lot of situations, in all situations, the majority of your horsepower come from a combination of the cylinder head and the camshaft. It's after you get to that point that you can start fine-tuning how much horsepower you have by doing different things in the engines. And one of those things is oil control. There's quite a bit of horsepower that can be found with oil control. The oil, so if we take a step back and look at what's going on above the crankshaft, you have the camshaft spinning in the bearings, you have the lifters that are constantly peeing oil onto the cam, and all of that is falling down on the rotating assembly. That creates just a parasitic drag on the rotating assembly. And believe it or not, oil can rob you of horsepower just by falling on the rotating bits. And it has been found that about 3% horsepower can be found. So if you had a 1,000 horsepower engine, you can gain about 30 horsepower. A 600 horsepower, you can gain about 20 horsepower. So this is a viable option. Now, it's whether it's up to you or not, whether it's worth the expense and the effort and the installation to go through it. But in this situation where I'm messing with a dyno mule and it's a smaller inch motor and we're doing a lot of custom things in this engine, I'm going to take the opportunity to not only gain some horsepower, but to test this scenario that I have been playing with for many years. So in the past, I've looked at doing this with FEs, and my first sample of doing this was several years ago, and I approached the problem with using a solid tube of bearing bronze. And I contacted a customer of mine who did a lot of aircraft machining, and he made to my print, he made a solid tube of bearing bronze. And I had the intentions that this would go in place of the cam bearings. Bronze can be very hard, especially when you're flooding it with oil. And I had intentions of making this tube the cam bearings. So it would contain the oil, and what I was going to do was drain the oil with tubing and drain it outside of the rotating assembly and return it back to the oil pan. There was a couple of things that kind of bit me on that, and the first thing was doing the holes for the lifters. So when you introduce holes in the lifter for the lifters, then you pretty much breach your oil containment, and you kind of nix the whole idea. So then I had some bronze lifter bore bushings put in, and that kind of posed issues in and of itself. We were able to get around all of that, but at the very end, I could find nobody in my area to finish the ID of this bronze bushing cam tunnel. It was too small for line hone mandrel to fit in, and it was too long for any of the machine shops around here that had a large boring bar on a lathe setup. So the idea got nixed. So that brings us back to the present. There are all kinds of engine blocks that are available these days with a enclosed cam tunnel built in. Most of your Cup engines, your NASCAR blocks from Dart and a couple of the other manufacturers have these built in, and they're made for roller cam bearings, and they're made for dry sump situations where the block has fittings already in place that you can scavenge from with a dry sump pump. FE blocks are not made that way, and it would take a tremendous amount of effort to have an aftermarket block made that way to where that was already in place, and just by the architecture and the dimensions that you have, you're pretty much impossible to try to fit a roller cam bearing in there with an enclosed cam tunnel. You can run a roller cam bearing in an FE, but it wouldn't work with trying to fit something like this around it. So this is take two. Okay, this is the new idea, and I try new stuff out on dyno mules. That's what they're there for. And I would not just pop this out and send it to a customer. But I contacted, well, I put a feeler out on one of the forums, and I'm not going to give away the guy that was a huge help to me on this. He owns a machine shop up in the Northeast, and he has been invaluable to me with this, and had some input and some ideas throughout the whole process and helped me get it going. I'm not going to give his name right now. I want to get a little bit farther in the project and make sure that everything's kosher before I say who that is. I will give credit to whom it's due, but I just want to get a little bit further and make sure that it's all going to work together. So let's just take a second and look at this. This is our in place of our cam bearings. So typically in FE, this is an F33 cam bearing set. This is the front bearing. They're made out of Babbitt and aluminum for the most part. Bearing bronze is very hard, and it's what it's made for, and especially when you flood it with oil, then you add a lot more aspects of longevity there. So this is the rear cam bearing, and I've already drilled it for the oil feed, and it has been drilled and tapped for these sheet metal cover plates. So as we go, there will be some logistics into installing this. Hopefully I will be able to play with it a little bit next week. We'll see. But these just overlap. This is number 4. It has been notched to clear the lifter bores. Okay. And 4, 3, 2, 1. And this one's been notched for the distributor gear. And I've also drilled the 2 holes for the feed holes and to oil the thrust plate and also the distributor gear on that one. This is the front cover plate that will go on with a little dog leg around the distributor gear and some really good weld beads. Those are beautiful, and they're so tiny. I've never seen anything like that. But that'll cover everything. So he also made this install tool. Obviously, the logistics involved in this is all of these screw bolt to each other, and we need a way to keep that all in line as we drive them in. So he made me this nice install mandrel, and if I put a screw in each one of these, then I can keep it aligned as I get it started, and then probably I'll either use my cam bearing install tool or use this with another section of solid aluminum on the other end to drive it in. It'll be a trial fit, test fit, you know, as I go type scenario, and I think there'll probably be a little bit of fitment with the cover plates around the oil bosses in the block and that sort of thing. But once all of them are in place, then I'll use just a little bit of sealant or epoxy or whatever. I kind of get the wild hair to use something that will be heat and oil resistant and won't give me any issues inside the engine to seal it off. So if we're looking from top down, this would be with the engine block upside down. So if we're looking from the top down, then you can use your mind's eye here, and the lifters will be coming in at here. This will be sealed. These edges will be sealed to the block. They'll be sealed around here. So the oil will fill up in the cam tunnel, and then it will drain in the front and the rear of the lifter valley. And there will be some other things that I'll have to do to vent the block, since it will be separated from the top, and the top of the block and the bottom of the crankcase will be separated from each other. So we'll have to vent the block top and bottom to keep any combustion pressures from doing things we don't want them to do. So this has been, like I said, enclosed cam tunnels have been used for a very long time. On blocks that did not come with these from the factory, there's several ways of doing it. Most guys run just a standard cam bearing set, and then they'll pound out some kind of a sheet metal cover and just JB weld or epoxy them into the block in between. I wanted something a little bit neater than that, and this will fit the bill. And all of these were made with shoulders, so that the sheet metal will have something to sit up against. So everything was just made just really high quality, and we made all these to the diameter of regular cam bearing set, so that we have the correct amount of press fit. And I'm just really interested in getting all this going. So I think I've alluded to this in the past. This is a dyno mule, and I said there's going to be a couple things that you guys have probably never seen before. This is number one. So you probably haven't seen an FE with an enclosed cam tunnel. Number two, I'll still keep secret for a while because we're still a little bit out on that one. But this is going to be a dyno mule that you will not forget, I'm sure. All kinds of combinations of parts that are going to be so wicked with each other. So I can't wait to get that going. The billet steel flat tappet crankshaft with billet steel flat tappet camshaft with the DLC tool steel lifters, enclosed cam tunnel, aluminum rods with a small displacement tunnel port setup, and we'll keep the other item a secret for a while. But so if you guessed enclosed cam tunnel, I saw a couple of you guys in the comments that nailed that. Good job to you. Wish me luck on this, and I think we're going to, I expect a little bit of fitment, you know, bumps in the road, but that's what die grinder bits and belt sanders and that sort of thing are for. And we'll get this installed, and if everything turns out perfectly, then our goal is to offer these as a kit for sale. This one is for a side oiler, and just remember that side oiler cam bearings and stuff are different than your regular center oiler, top oiler, you know, 352, 390, 428 stuff. So hopefully we can offer one of these kits for side oilers, one for top oilers, and maybe even one for your aftermarket block stuff. This is worth some horsepower. So we're just going to work out the details and get it going. But yeah, so here we are. So again, if you haven't subscribed, this is one of the reasons why you want to subscribe, so that you do not miss out on this kind of stuff. I love Ford FEs. I've spent the past several years of product development for straight for FE stuff. I've done the one-piece laser cuts, rocker arm stands, shims, the adjustable pointers, enclosed cam tunnel stuff. So I really want to see the FE, be brought up in the same levels as the other engine families, and get the same goodies as they get. So hit that subscribe button and hit that like button. That helps me out. This stuff costs money, and this is not customer fed money. This is Brent's money. So all those like buttons and like things that you hit, and the subscriptions and the ads that you watch, and all that stuff, that helps me to pay for all these goodies, which in turn helps me to build a better engine for you. So thanks. All right, you guys have a good weekend. I'll talk to you soon.